Welcome to Math TV with Professor V. It is Thursday, February 23rd, 2023. Here's your integral of the day. Warning, it is probably one of the spiciest, trickiest integrals I've recorded. And it uses pretty much every single integration technique out there except for integration by parts. But I would definitely never put this on an exam. I think that's way too mean. There's no point in punishing your students. If it ever made an appearance, maybe like an extra credit problem. If someone did put it on an exam, this could be the only question. Anyways, okay, if you want to pause the video and give it a go, it's going to take some work though. Right off the bat, you're probably thinking, okay, let's do some partial fraction decomposition, which yes, that's where it's going, but x squared minus 4x plus 6, that's prime. It doesn't factor. So we have an irreducible quadratic in the denominator squared. Do you remember how to find the partial fraction decomposition? Ooh. So I'm just going to leave this beast as it is. And then remember, since we have a repeated factor, one time I have to list it as x squared minus 4x plus 6. And then the second time I'm going to put x squared minus 4x plus 6 quantity squared. And then in the numerators, I need ax plus b and cx plus d since I have irreducible quadratics in the denominator. If you're rusty on your partial fraction decomposition, don't worry, I have a video. I'll link it in the description if you need to review. If you don't do it every day like me, of course you're gonna forget. That's normal. Okay, our job is to find a, b, c, d. So to do that, we're gonna multiply everything through by the LCD, which is in this case, x squared minus 4x plus 6 squared. So on the left-hand side, we just have x squared minus 3x plus 7. When I distribute, one of the factors will cancel, but I still have one remaining x squared minus 4x plus 6 that gets multiplied by ax plus b, and then cx plus d is by itself. I do have to multiply this all out. I can't plug in values for x to zero out and find the constants the way we've done in previous situations because the quadratic is irreducible. So we just FOIL our little hearts out. Here we go. This is going to be ax cubed minus 4ax squared plus 6ax. I'm just going to keep it going. No more rainbows. Plus bx squared minus 4bx plus 6b plus cx plus d. Whew. Okay, it looks worse than it really is. So now what we're going to do is collect and equate coefficients from like terms. What do I mean? Highest power of x I see is cubed, right? So let's see. What is the coefficient of x cubed on the left-hand side of the equation? I don't see any x cubed, so that's 0. What is the coefficient of x cubed on the right-hand side of the equation? Why, it's ax cubed. So that means a is 0. Okay. Moving on to x squared. What's the coefficient of x squared on the left-hand side of the equation? It's 1, right? There's a 1 in front of the x squared. Okay. What are the coefficients of x squared on the right-hand side? So we've got negative 4a plus b. Well, I've already established that a is 0, so that means b has to be 1. Okay, keep going. X to the first. What's the coefficient of x to the first on the left-hand side? Negative 3. And negative 3 is going to equal 6a minus 4b plus c. Well, I already know a is 0. And I know b is 1. And then if I add 4 to both sides, I can determine that c is equal to 1. And then lastly, we have to figure out what the coefficients for all the constants are. So notice 7 is the constant on the left-hand side. What are my constant terms? The ones that don't have x in them. 6b plus d. Well, I already know b is 1, so 7 equals 6 plus d, so d is 1. Okay, That means if a is 0, I have 0x plus 1 in the numerator here, and then c is 1, so that's 1x plus 1. What I'm going to do now is rewrite the original integral using the partial fraction decomposition and break it up into two terms. 1 over x squared minus 4x plus 6, and then x plus 1 over x squared minus 4x plus 6 squared. Okay, here we go. So now, let me write you a little narrative. Now we have the following. Yay. So b was 1, a was 0, so I don't have any x's in the numerator here. X squared minus 4x plus 6 dx plus, and then the other one is x plus 1 over, this time the denominator is squared, right? So x squared minus 4x plus 6 squared dx. We're going to tackle these separately. So I'm going to call this integral number 1. I'm not calling the other one number 2 just yet. You'll see why. Don't call it integral number 2. So for integral number 1, what to do? Well, we have a constant over a quadratic expression. And what we're going to need to do is complete the square. Okay, so x squared minus 4x plus 6. X squared minus 4x plus 4 is a perfect square trinomial. So I'm going to steal that 4 from the 6 and just break it up into 4 plus 2. Okay, now I'm able to rewrite the denominator as the whole thing is 1 over x minus 2 squared plus 2 dx. Why is that good? Well, this is where it's important that you really memorize all your basic antiderivatives. Antiderivative of 1 over x squared plus a squared dx is, do you know? Yes, 1 over a tan inverse x over a plus c. If you didn't know that though, then you wouldn't be inspired to complete the square and put it in this form, you know? So you have to have this arsenal ready. The arsenal of already memorized integrals. Okay, so here we go. Basically, instead of x, we have the quantity x minus 2, no big deal. And then this is a squared, so a is square root of 2. And then we're just ready to jump to what the antiderivative is. So 1 over rad 2 tan inverse x minus 2 over rad 2 plus, I'm going to say c1 because this is the first integral. Okay, good. That was pretty harmless. That's where the ease of the problem stops. So now remember we had waiting for us this other integral, which, you know what, I'm just going to copy it. So here we go. Back to this guy. Let's deal with this. So since the denominator here is squared, we cannot take the same approach that we did before. But I do want to still complete the square in the denominator. That's usually the way you need to handle these little funky ones. So we've got x plus 1, and we already know the denominator can be broken up into x minus 2 quantity squared plus 2. But then remember, all of this is squared, okay? Dx. Now, if you've gone back, I did something pretty similar in a previous integral of the day. I'm going to make a u substitution and let this entire quantity inside the parentheses, just basically except for this squared part, be u. If I let that be u, right, it's degree 2, then du will be degree 1. So I'm hoping that'll get the ball rolling, but I am going to have to tweak things a little bit, okay? So let's start off, let's say let u equal x minus 2 quantity squared plus 2, that part. Then du would be, use the chain rule, 2 times x minus 2 dx. So that means 1/2 du equals x minus 2 dx. And I would be oh so excited if instead of x plus 1, I had x minus 2 sitting up there, right? So we're going to make it happen. So I have x plus 1, but I wish it was minus 2 instead. So subtract 2, add 2. Then you can regroup it. You can break it up into x minus 2 plus 3. because these two come together. There's your 3, and then now I've made an x minus 2. So what we're going to do is actually create 2 integrals from here. One of them is going to have a u sub, and then the other one I'm going to tackle later. So let's rewrite this now as x minus 2 over x minus 2 squared plus 2, all of this squared dx, plus integral, and then, just so you see what's going on, this is here, and then I need another one now for this little 3 over here, right? 3 over x minus 2 squared plus 2 squared dx. So this will be integral number 2 that I do, and this will be integral number 3. I didn't break it up though earlier because you don't really realize what this is going to be until you start trying to handle this second part. Do you get what I'm saying? Okay. So anyways, we're pretty much set up to evaluate integral number 2 because we're going to use this u substitution for this guy. This we'll talk about later. Here we go. So we have the substitution here. X minus 2 dx is 1/2 du. Okay, so 1/2 integral du over, and then remember, u is all of this, so that's sitting inside here. So we have a u squared in the denominator. Whew, that cleaned up so cute, right? So this is 1/2 integral, write it as u to the negative second du. Add 1, divide by the new exponent. It's going to be negative 1/2 u to the negative first plus, this is c2. Very good. This is negative 1/2 times 1 over, what was u? It was x minus 2 squared plus 2. Plus c2, and then I'm just going to multiply out that denominator and write it how it originally was. So we have negative 1 over 2 times x squared minus 4x plus 6, just like that, plus c2. So second integral is done. We've just got one more to tackle. How are you feeling? Okay, so here's the third one. Let's copy it and knock it out right now. Okay, the u sub won't work because we have this squared term, but there's no x's up here. It's just a constant. And so it's giving me reminders of tan inverse, but we can't do tan inverse because this quantity is squared. If you scroll back to the very first integral, it was just x minus 2 squared plus 2. This was not here. That's why it worked out to just be a form of tan inverse. What do? We're going to do a trig sub, and it's going to involve tangent. It will, but it's going to take some more work. So trig sub time. That's why I'm like, this problem really uses every integration technique. What substitution is appropriate? Well, we've got a variable squared plus a constant. So here we go. It's tangent time. Let x minus 2 equal rad 2 tan theta. If you're rusty on the trig sub, I got a video for you, so check out the description box. I have all the links there. Let's take the derivative. dx is going to be rad 2 secant squared theta d theta. Okay, so now we have integral 3. dx is rad 2 secant squared theta d theta. And then in the denominator, x minus 2 squared is going to be rad 2 tangent theta squared plus 2, and then this is all squared, okay? Now I don't want to rewrite this 100 times, so let's clean this up over here. That's going to be 2 tan squared theta plus 2, all squared, which is 2 times tan squared theta plus 1, all squared, which becomes 4 times secant squared theta squared. So it's 4 secant to the 4th theta. Oh, wow. Okay. So now I'm going to take all the constants out. They're bothering me. 3 rad 2 over 4. And then we have secant squared theta d theta over secant to the 4th theta. So good. So secant squared from the numerator cancels. Now I just have secant squared in the denominator. But you guys, secant squared in the denominator is the same as having cosine squared in the numerator, is it not? It is, it is. And how do we integrate cosine squared theta? You got to turn on that robot mode. You go, oh, I use my half angle identity. There's no other way. You replace cosine squared with 1/2 times 1 plus cosine 2 theta d theta. I got too excited there. Forgive me. Okay. Constants on the outside. So 3 rad 2 over 8. And then you should be able to integrate this. Antiderivative of 1 will just be theta. Antiderivative of cosine 2 theta, 1/2 sine 2 theta, plus, C3. Okay, now since we did the trig sub, we have to go back to X land. So we're going to need to draw a triangle. And the triangle is going to be a theta triangle, not a 2 theta triangle. So we have to use our double angle identity to get rid of sine 2 theta. I mean, what have we not done in this problem? 3 rad 2 over 8 times theta plus 1/2 sine 2 theta is 2 sine theta cosine theta plus C3. So the 1/2 and the 2 cancel. And then now think back, we let x minus 2 equal rad 2 tan theta. So how do you draw a triangle with that? Get the trig function by itself. So x minus 2 over rad 2 is tan theta. And then you draw yourself a triangle, right triangle. Here's theta. Tangent is the ratio of the opposite over the adjacent side. And then using the Pythagorean theorem, the hypotenuse is going to be square root of x minus 2 squared plus 2. But we know that. That's x squared minus 4x plus 6. You should always get back an expression that you saw in the original integral when you're setting up your triangle. Okay. So now we're going to use the triangle to rewrite everything in terms of x. Now, when you've got just plain old theta, what do? Come right here. Theta by itself is tan inverse of the left-hand side. So theta is tan inverse of x minus 2 over rad 2, like that, plus sine theta will be ratio of opposite over hypotenuse. So that's x minus 2 over rad x squared minus 4x plus 6 times cosine theta, which is adjacent over hypotenuse. Same denominator. Rad x squared minus 4x plus 6. Close it up. Plus C3. Okay, and then I'm just going to distribute through so everything's nice and cleaned up. And we have 3 rad 2 over 8 tan inverse of x minus 2 over rad 2 plus, now when I multiply these two denominators, the radical goes away, right? Square root of something times itself is just the original quantity. So we just have x squared minus 4x plus 6. And then let's look at all the coefficients. So we've got a rad 2. Don't worry about the x minus 2, okay? Don't worry about that. Rad 2 times 3 rad 2 over 8. So 3 rad 2 over 8 times rad 2, that's 3 times 2 over 8. Yes? Which is 3 over 4, okay? So I want to write it cleaner. So I'm going to put, this should be closed, 3 times x minus 2, and then I'll put a 4 down here, like that, plus C3. Are you good? Did I lose you? You're okay. All right, fabulous. So that's all 3 little baby integrals. They weren't so baby. They were gargantuan. So now we're going to put it all together. I'm going to continue my narrative. At long last, we have, imagine if you did that on a test. That would be cute. I would chuckle if a student wrote that. Okay, I have all three written here so I can reference them. So we've got 1 over rad 2, tan inverse of x minus 2 over rad 2 minus 1 over 2 times x squared minus 4x plus 6 plus this most recent addition to the family, we birthed it, 3 rad 2 over 8 tan inverse x minus 2 over rad 2 plus, you know what, I'm going to distribute this. Why? Because I know what's coming in the future, okay? So 3x minus 6 over 4 times x squared minus 4x plus 6 plus c, and c is c1 plus c2 plus c3. You just have to say it once. Can we clean it up more? Don't punk out now. Don't be like, oh, I've done enough. No, you haven't. Look at this. We've got a tan inverse here and a tan inverse here. Can we combine their coefficients? Yes, you should be able to do that. 1 over rad 2 is rad 2 over 2 plus 3 rad 2 over 8. Let's multiply this one by 4 so we have a common denominator. So 4 rad 2 plus 3 rad 2, that's 7 rad 2 over 8. See, that wasn't so bad. Okay. Don't be intimidated. You have the skills that you need. No one's asking you to invent new math. Calculus has been around for hundreds of years, so don't overthink it. I always tell my students that. It's just algebra on another level. Think of it that way, okay? Those are those two terms. Now I'm looking here. Are you ready? Can we get a common denominator? Yeah, it won't be that hard. It won't. The only difference is I see this guy has a 4 in the front, this one has a 2. So I'm just going to multiply by 2. There we go. Done. Done and dusted. So now this is a negative 2 in the numerator, okay, plus 3x minus 6. So that's going to give me 3x minus 8 over 4 times x squared minus 4x plus 6 plus c. You know how they say mic drop? I'm going to do stylish drop and then walk away, if you can imagine that happening. Mwah! This is beautiful. I love it. I love it. Why? Because it's not for the faint of heart. But, you know, like I said in the beginning of the video, I'm not into testing my students with these sorts of things. I want to see what they know. I don't like to torment and terrorize them on exams. I just want them to be rewarded for the hard work and studying that they did. That's just me though. Everyone's different. What can I say? Give the video a thumbs up. Comment if you made it to the end. I can't believe you're still watching. This was not an easy integral. I think definitely probably like the hardest one, right? That I've done thus far. Subscribe if you haven't already. Check out my video lectures organized into playlists if you need help in your current math classes. And you can also check me out, follow me on Instagram and TikTok at Math TV with Professor V. Have a great Thursday, you guys. Talk to you soon.